All right, so in the last section, we talked about, excuse me, studies. And in this section, we are going to talk about experiments. So, an experiment by definition is a controlled study conducted to determine the effect of varying one or more explanatory variables or factors. So we can call explanatory variables factors, so they mean the same thing in this case. We are determining the effect that varying those variables or factors has on a response variable. So if, for instance, we are interested in doing a study on high blood pressure would be the response variable, and then there are lots of factors that might affect blood pressure, so perhaps diet, exercise, genetics, medication, all of those things. A treatment is any combination of values of those factors or explanatory variables. So what, are we having this person eat? What medication are we having this person take? So it can be a combination. It doesn't just have to be one particular value. Experimental unit is a person or animal or other well-defined object upon which a treatment is applied. The subject is what we call the experimental unit when they are a person. So if we are doing a study that involves people, we typically call them subjects. If it is not using people, then we go with experimental unit. Within the experiment, we have a control group. That is the group that essentially serves as a baseline treatment used to compare it to other treatments. So the control group is typically not receiving, the medication or the diet or whatever it is that we are varying in the factors. Placebo is often used especially in medical studies, for the control group. It's a treatment that looks just like the real treatment. So the reason why they do this is there have actually been studies that show that there's something called the placebo effect. So meaning that if you don't use a placebo, that even the fact that people think they are getting medication sometimes causes differences in the response variable. So they use placebo so that everyone in the experiment, could have thought that they might be receiving the medication. So looks, feels, tastes just like the real treatment typically. Then within an experiment, most good experiments have what we call blinding, which is non-disclosure of the treatment that an experimental unit is receiving. So meaning that we don't tell what group they're in. So that blinding can be single blind, which just means that the subject doesn't know which treatment they're receiving. Or it can be double blind, when the experimental unit nor the researcher know which treatment they're receiving. So if we have a double blind experiment, then that means there has to be some third party who's basically the keeper of the assignments. So that, person knows, that this subject is assigned a placebo, this subject is assigned a medication, but the subjects and the researcher conducting the experiment do not know which subject is in which group. Replication is something that's super important with experiments, and that occurs when each of our treatments is applied to more than one experimental unit, which this seems like common sense that you need to try it more than once in order to have any level of confidence in the results. So the more replication we can have, the more confident we feel in the results. So replication not only within the experiment itself, that, maybe we have 1,000 subjects in our study, and the treatments are applied, to those various subjects. But also, sometimes we replicate the entire study. So maybe one research group comes up with a study and says and publishes, these were our results, these are our findings. And then another group thinks, oh, that's interesting. And then they replicate it to see, do we get the same results that they did? And the more replication you have, if the results are the same, then the more confident you feel in those results. Within our types of experiments, we have 3 main types of designs. So in your practice, it's going to ask you to classify which design this particular experiment has. So completely randomized is when the experimental unit is just randomly assigned to a treatment. So we don't do any type of separation first. We just take the entire pool of subjects. So here's 1,000 people, and boom, 500 of you go to placebo, 500 of you go to the medication. So there's no type of organization first, just everybody's put, in a big pool, the frame's created, and then we use, a random number generator or some other type of randomization to assign each experimental unit to one of the treatments. And it doesn't have to be 2 with completely randomized design. You might have multiple treatments that you're randomly assigning to. Matched pairs design is going to have groups of 2. And that is when you have experimental units that are related in some way, paired up for 2 levels of treatment. So when we say related, that doesn't necessarily mean that they're family, right? They don't have to be people, but there's something about them that makes them similar. So you might just be pairing people, I've got 2 people that are 47 years old, and one of them goes to one group and another goes to another group. It might not even be people. It could be, let's say we're doing a study of software on various devices. So maybe I've got 2 MacBook Airs and, 2 Chromebooks and 2 iPads. And so I've matched the units in some way to be related. So the 2 MacBook Airs obviously related to each other because they have the same setup, the same memory, all that kind of stuff. And then we assign one of them to one level of treatment and the other to the other level of treatment. So matched pairs, we're always pairing up first and then assigning one to each of the treatments. So if it's going to be matched pairs, you have to have 2 levels of treatment, and that's it. Can't be more than 2. Randomized block could be 2, could be more than 2, but it's when experimental units are divided into homogeneous groups called blocks. So again, homogeneous means the same. So there's something that they share that's all the same. And within each block, then the experimental units are randomly, can't get it to go to the place I want, randomly assigned to the treatments. So an example of this might be if I were doing a study of students at our school. I might randomize block by grade level, for instance. So I have grouped all of the subjects into grade levels. So I've got one homogeneous group of 9th graders, 10th graders, 11th graders, 12th graders. Then within each block, then I do the randomization. So the randomization isn't the first step. Dividing them into blocks is the first step, and then we use the randomization to assign the same number of experimental units from each block to each treatment. So again, this is going to be kind of the main objective here, is to make sure you understand the different types of designs and can identify them. So steps in designing an experiment, pretty self-explanatory. Identify the problem that we want to solve. Determine the factors that might have an effect on that response variable. Determine the number of experimental units, so how many people or, computers or animals do I have to divide into the groups? So when you think about in step 2, the factors that affect the response variable, then I have to determine the level of each factor. So am I going to control that factor, or am I going to randomize that factor? So it's controlled if you set the level of a factor at one value for everyone. So if everyone that is part of the study, has, the same age group or the same gender, or there's a factor that we're not interested in its effect on the response, so it's just one level the whole time. Or you can control it by setting the factors at various levels if you're interested in seeing the effect. So for instance, if I am going back to blood pressure being a response variable, if I'm interested in how the factor of gender affects that response variable, then perhaps I do some sort of blocking where I divide genders first and then assign to the levels. If you don't want to control, then we randomize. So again, we've considered the factor, we've considered the explanatory variable, but if we do not want to control it, then we need to randomize it, because randomizing helps to mute the effect of variation. So again, it's impossible to control all of the factors that might have an effect on a response variable. So that is why the randomization is so important, because it helps mute the effect of those variations. When we conduct the experiment, we need that replication. Equal number. When it says equal number here, it doesn't have to be perfectly equal. If you are doing an experiment and you have 1,000 subjects. 1,000 is a pretty big number. If you have 5 more subjects in one group than another, that's a very small difference when compared to the sample size. However, if I'm saying 5 is not a big deal in that case, if our total sample size was 20, and I had 5 more in one than in another, then that would be a big deal, because in comparison to the overall sample size, 5 is a large percentage. So when we say equal number, that's relative. It needs to be close, and the smaller the sample size is, the closer it needs to be. So if you're dealing in tens, you really don't want to have a difference of more than 1 or 2. We collect and we process the data, and then we test the claim. Testing the claim, again, is what we will do at the very end of this course, where we get to use inferential statistics. Okay, so here's an example of what you are going to see in your practice. A statistics instructor wants to see if allowing students to use a note card on exams will affect their overall exam scores. The instructor thinks that the results could be affected by the type of class, traditional, web enhanced, or online. He randomly selects half of his students from each type of class to use note cards. At the end of the chapter, the exam score for those using note cards is compared to the exam score for those without note cards. Okay. So that's the situation. Then we have a bunch of questions to answer about it. A, what type of experimental design is this? So first, we need to decide, is there any level of organizing, or is it all just one group and then randomize? In this case, it's not just one group. It says that he's randomly selecting from each class type, so meaning that they're grouped by type of class first. So if we are grouping by type of class first, then that means that this is randomized block design, because the blocks are the type of course. So I've got a block for traditional, a block for web enhanced, and a block for online. Then the randomization occurs. What is the response variable in this experiment? So again, the response variable is what we're interested in seeing a difference in. And in this case, the instructor is interested in seeing if there's a difference in the exam scores. So exam score is the response variable. What is the factor that is set to predetermined levels? So meaning that the instructor is saying you have this and you have that. So that in this case would be note card use, because that is being predetermined by the instructor. It's not just, something, like your eye color or your GPA or whatever. This is set to predetermined levels. The instructor is saying, okay, from this randomization, this person is selected to use a note card, this person is not. So, note card use is set to predetermined levels. The treatments are the groups that are part of note card use. So, in this case, the groups are using note cards and without note cards. Can't spell. So, note card use is the factor. The two levels are using note cards and without note cards. D, identify the experimental units. So in this case, the experiment is being conducted on this instructor's statistics students. Now, if we knew how many there were, we would include the number in there, but they didn't tell us in this case how many statistics students that they had. So if it said, 500, we would put 500 in there. All right, last one, draw a diagram to illustrate the design. So something that is very, very important, that is the most commonly missed item when it comes to this section, is that when you are creating a design and a diagram, you need to include the numbers or percentages if they are given, and be specific. So I'm going to explain what I mean as I go through this and actually create this. So what we are doing is we're creating the design. So let's just say, and this is not this answer, so you do not need to write this part down. I'm just, giving an example of a different type that's not this one. Then we're going to do this one. So let's say that I had a completely randomized design, and again, we're just going back to blood pressure since that's what I used at the beginning. But let's say it's completely randomized and we're randomly assigning to placebo or medication. So let's pretend that I had 1,000 patients, ages, 40 to 65, and those were my subjects. So if this were that particular experiment, that's how I would start. And then I would say, all right, now I need to assign them randomly to those two groups. And so I would draw little lines, and then I would say, okay, what are the two groups? Be specific with the numbers. So let's say we were able to get this pretty close to half and half. So let's say I had 505 in the placebo, and I had 495 in the medication, right? So this is kind of how you would set it up if it were completely randomized. You've got the specifics, you've got the numbers, and then at the end, we're looking at, okay, what are we trying to find out from those groups? So perhaps we are then comparing these two, and again, the important thing is to be specific. So I would say compare blood pressure readings, perhaps. So again, noticing how noticing how I have not just the numbers, but I also am specific. So I'm not just saying compare, I'm saying what I'm comparing. I'm saying how many patients. I'm being specific about their ages. So the details need to be included when you are creating a diagram. So that's just an extra example of a diagram. Now we're going to do one for this particular example. So because this is randomized block design, the first thing that we're doing is determining which block a experimental unit or subject is going to. So determine course type of statistics student. And again, if we knew how many there were, we would include that, but we don't, so we have to leave it. Once we are set to determine, then we actually have to create those categories. So in this case, the course type, we have 3 choices. 1, 2, 3. And those choices are, oops, clicked on the wrong one there. We have traditional, we have web enhanced, sorry about the dogs, and we have online. So those are our blocks. We've now determined anyone can look at this diagram and see, okay, I'm talking about statistics students. The blocks are by course type and what those course types are. Once we are in the individual block, then we can do the randomization. So the randomization here was with the arrows. Again, notice that we said how many. In this case, we don't know the numbers, but we are told that it's half. So you can either write half or 50%. Doesn't matter which you choose. Obviously, they mean the same thing. So within each block, then I'm going to have 2 sections that come out of that. So again, the 2 treatments that are being randomly assigned, so this in this example that I made up, the 2 treatments were placebo and medication. In this example, the 2 treatments are what we talked about in C. They are using note cards and without note cards. So for traditional, I have use note card, and then I have without note card. And then we're obviously repeating that. So I think I can just copy. Yep. So for web enhanced, use note card, online use note card. And then again, because we are having those 2 levels of treatments for all 3 blocks, then I've got without note card on all 3 blocks as well. Does not want to let me move it. There we go. Again, just doing the randomization is not the experiment, right? We have to figure out what we're looking for at the end. So in this case, we're comparing, and this is how we draw compare, right? We draw arrows to each other. In this case, the arrows are within each block because I am comparing within each block those who used a note card with those who were without a note card. Because again, the instructor is hypothesizing that the course type is going to have an effect on the results. So again, just guessing, it's more likely that a traditional student is going to see a bigger difference in exam score with using versus not using a note card. So we are then going to write out in our compare, and again, be specific. Compare exam score. Now I need to make that a little longer. There we go. And then we'll repeat. Now, again, I am missing something that is very, very important because I have to use the copy paste feature here. I'm going to go back in and write this very important part. Again, over here I wrote 505 and 495. We don't have that here. I don't know what the percentages are, but I do know that it's 50% or half. So that would be included. So I would write 50%. I knew I was short on space, so I figured it would be better to write it on top. So 50% of the traditional use a note card, 50% of the traditional without a note card, and then the same for each individual block. So including the numbers, in this case, would be percentages, or you could write out half of students, right? So 50% for each. And again, at the end, we're comparing those who used a note card to those who were without a note card for each individual block. Okay, hopefully that makes sense. And I've given you kind of two different examples for how to draw a diagram. That's usually where people struggle the most, is on the diagrams. So hopefully that makes sense, and let me know if you have questions.